Last time, we looked at how cities finally stopped burying their heads in the sand and started building massive brick arteries to move waste away from their streets. We saw how a few visionary builders realized that a unified network was the only way to stop the cycles of disease that were killing thousands. This shift transformed the city from a collection of isolated house lots into a single living machine that could support millions of people at once. But once those giant tunnels were under the ground, a new and much more complicated puzzle appeared. It was one thing to dig a massive tunnel under a main boulevard, but it was another thing entirely to make that tunnel work for every single person in the city. The real challenge was a scaling trick that almost nobody talks about today. You had to find a way to connect every kitchen, every bathroom, and every basement to that main line, without the whole thing turning into a disaster of smells and backflows. Think about the sheer physics of a city. On a rainy day, you have millions of gallons of water rushing off the rooftops and into the streets. On a dry day, you only have the steady trickle of household use. If you build a pipe big enough to handle a massive storm, the tiny amount of water used on a normal Tuesday will not have enough force to push anything along. The waste just sits there and rots. If you build the pipe small enough to keep things moving during the dry spells, it will explode or overflow the moment the clouds open up. This was the silent engineering bottleneck that almost broke the first modern cities. They had the big idea, but they did not have the math to make it work at scale. The breakthrough that saved the system was a piece of clever geometry that we still use today. Engineers realized that if they changed the shape of the pipes, they could cheat the laws of physics. Instead of simple round tubes, they began to build egg-shaped pipes. The narrow bottom of the egg meant that even a tiny amount of water would be squeezed into a deep, fast-moving stream that could carry away debris. When the heavy rains came, the wide top of the egg provided all the extra space needed to prevent a flood. This was the scaling trick that allowed a city to grow from a few thousand people to several million without the ground beneath them becoming a ticking time bomb. It was a triumph of fluid dynamics, hidden behind layers of brick and mortar.
But the engineering of the pipes was only half the battle. The other half was the transition from a private problem to a public standard. Before this era, if you wanted to get rid of waste, you were on your own. You hired a private contractor or you dug a hole in your yard. The shift to a modern sanitation system required a level of coordination that humanity had never really attempted before. It meant that every single house had to follow the same rules. You could not just use any pipe you found. You had to use specific materials and specific sizes so that the entire city functioned as one single unit. This was the birth of the building code. It was the first time that the government reached inside the walls of a private home to ensure that the plumbing met a universal standard. This standardization created a massive new industry. Suddenly, there was a demand for millions of miles of ceramic and iron pipes. Factories had to figure out how to mass produce these items with incredible precision, because if one joint leaked, it could undermine the foundation of an entire city block. This was the hidden economic engine of the late 19th century. While the world was focused on steam engines and railroads, a small army of manufacturers was quietly perfecting the art of the airtight seal and the waterproof joint. This industrial scaling is what made the technology affordable for the average person. It turned a luxury for the rich into a basic right for the working class.
Imagine being a homeowner during this transition. For generations, your family had lived with the constant presence of waste. It was in the air you breathed and the water you drank. Then, almost overnight, the streets are torn up and these massive underground cathedrals are built. Men in muddy boots come into your cellar and connect you to a network that stretches for miles. Suddenly, the air in your home is clean. The dampness that seemed to cling to the walls for decades begins to dry up. You no longer have to worry about the person living uphill from you because their problems are now carried away by the same system that handles yours. This was the first time in history that a person could live in a crowded city and feel truly clean. The ripple effects of this scaling were felt in every corner of society. Property values in the center of cities skyrocketed because the land was no longer a health hazard. This created the modern downtown. Without this engineering trick, the skyscraper would have been impossible because you cannot have 1,000 people working in one building if you have no way to handle the output. The very shape of our skyline is a direct result of the plumbing standards developed over a century ago. The cities that invested in these systems first became the new centers of global power. They were the ones that could sustain the massive workforces needed for the Industrial Revolution. The cities that lagged behind remained trapped in cycles of poverty and illness. This history still matters because we are currently living on the borrowed time of these Victorian engineers. In many of the world's oldest cities, the brick tunnels and egg-shaped pipes laid down in the 1850s are still doing the heavy lifting today. We have built massive glass towers and high-speed digital networks on top of a foundation that was designed before the invention of the light bulb. The resilience of our modern world depends on a system that is almost entirely invisible to us. When we walk down a city street, we are walking over a masterpiece of coordination and physics that keeps us safe every second of the day. This engineering marvel shows us that progress is not always about the newest gadget or the fastest engine. Sometimes the most important technology is the one that manages the most basic aspects of our lives. It proves that a city is more than just a collection of buildings. It is a shared biological system that requires a high degree of technical precision to survive. The scaling of urban sanitation was the moment we realized that if we wanted to live together in large numbers, we had to think about the world beneath our feet just as much as the world above our heads. While we have been looking at how cities manage the results of their massive growth, we need to take a quick step sideways to see what was actually driving that growth in the first place. To understand why people were crowding into these cities so fast that they needed these sewers, we have to look at the machines that changed where and how we worked. The story of the spinning jenny and mechanized textiles is the missing context that explains the sudden explosion of the modern world. If you want to see how a single machine changed the clothes on our backs and the shape of our lives,